The primary objectives of this lab are for the students to demonstrate a proficiency in welding safety, amperage adjustment of a welder, understanding welding terms like travel speed and arc length, and demonstrating proper technique when welding surface beads, butt joints, lap joints, and T-joints. Throughout the course of this semester, the use of many different tools will be required in order to complete your various lab assignments. The first step in using a tool correctly and efficiently is being able to identify it while also knowing its specific function. The tools used in this lab include a ball peen hammer, a cold chisel, a pair of slip joint pliers, 6013 electrodes, an angle grinder, a wire brush, a slag chipping hammer, and a shielded metal arc welder, commonly known as a stick welder. PPE, or personal protective equipment, required for each lab can vary from week to week. It is important to stay up to date on the PPE to meet the safety requirements. The students' PPE for this week will include closed-toed shoes, long pants, a long sleeve shirt, safety glasses, leather welding gloves, a welding helmet, and a face shield. To start lab, you'll be given one 3x3 piece of metal for surface beads, and 4 2x3 pieces of metal for your welding project. While not all shielded metal arc welders look the same, they all have the same basic controls. An on-off switch, a way to adjust amperage up or down, in this case with a knob, a way to switch your polarity between AC, DC positive, and DC negative, an electrode holder, and a ground lead, commonly called a ground clamp. Before beginning, make sure your ground clamp is firmly attached to your welding table. A firm connection is required for the welder to function properly. To begin, grab an electrode and place its bare metal end into the electrode holder as shown. The welder has different holding positions as depicted. Choose the one that's most comfortable for you. To release the electrode, simply squeeze the electrode holder and pull the electrode out. There are 2 basic ways to strike an arc. One is the tapping method, and the other is the match strike method. For beginning welders, one of the most frustrating things is getting an electrode stuck. To properly remove an electrode, first turn off the machine, then remove the electrode from the holder, and finally break the electrode free. After this, you can put the electrode back on and turn the machine back on to try again. Maintaining a proper arc throughout a weld can be a difficult task for a beginner. For stick welding, 2 main factors are controlled by the operator and need to be perfected. One is arc length, which is the distance from the tip of the electrode to the work surface, and the other is the travel movement, or the speed of the rod across the workpiece. Arc length can be difficult to control because the electrode must constantly be fed down. Think of it this way. As we are welding, we're transporting metal from our electrode onto our workpiece. This means that over time, as more metal is transferred from our electrode, the electrode gets shorter. As the electrode gets shorter, the position of the tip changes and so does our arc length. In order to maintain a constant arc length, in our case, 1/8 of an inch, we need to steadily feed our electrode down. Travel movement is also very important. As we are welding, not only are we controlling our feed rate into the weld, we are also controlling the rate horizontally across our workpiece. If this is too fast or too slow, we could inhibit the puddle formation, resulting in a bad weld. Proper amperage is essential to all forms of welding. If the amperage is too low, as shown, it will be difficult to keep the arc up for any period of time. A low amperage like this also has very low penetration, which makes for a bad weld. The correct amperage you should be running in this lab should be around 120 to 135 amps as shown. 135 amps gives us good penetration while also minimizing the amount of spatter we have. Higher amperages, like the one shown, tend to create more spatter. Spatter is molten material that jumps out of the weld puddle. It leaves small bumps of residual metal all over the piece. To clean this, get a cold chisel and a hammer and knock these pieces of spatter off of your piece of metal. Prior to starting your project, you'll need to run some practice speeds on your 3x3 piece and get them approved by your TA. After striking an arc, maintain the arc length and the travel speed at a slow, steady pace. For a pattern, small circles are being used in the current view. To stop welding, simply lift the electrode up and break the arc. After welding, a thick black coating of material will remain. This coating is called slag. Slag is the result of the outside covering of the electrode, called flux. Slag protects the weld from atmospheric gases, helps puddle stability, and helps with cooling. Before cleaning the weld, use a pair of slip joint pliers and quench it in a quench bucket. Then, using a chipping hammer, gently chip the slag off the weld. Use a wire brush to clean off any residual slag. Arguably the most desirable look in stick welding is the stack of dimes. In other words, the weld's appearance is supposed to look like a stack of dimes knocked over. This is a good gauge of weld quality, as dimes are close to the appropriate diameter and the thickness of the dimes overlap generates a good model of how the weld should look. However, dime-like patterns aren't the only way to go, and various methods of surface welding exist, such as the half-moon style and even a zigzag pattern. Differing patterns yield different styles of weld formation and coverage. Once your welds have been approved by a TA, feel free to start your project. Before we talk about the project, let's talk about some common mistakes experienced by most first-time welders. The first is long arcing. This happens because of too long of an arc length. Next is moving too fast, and this obviously happens because the operator is moving too fast for the weld. The last one deals with non-uniformity. This occurs when an operator does not move in a continuous pattern. First, let's observe long arcing. From this view, we can see our puddle, and we can see an overview of how the rods are being manipulated. You can see here that the arc length is incredibly great, and instead of seeing a concentric puddle form, we see what appears to just be flame coming out of the tip of the electrode. Also, if you notice on the right side, an immense amount of light is generated from a long arc. Long arcs tend to show little or no puddle formation, and they leave a large amount of spatter. Next is moving too fast. We can see here from this view, arc length appears to be okay, but we're moving incredibly fast, not letting the puddle take proper shape. Moving too fast tends to leave narrow, underdeveloped puddles. Next is a lack of uniformity. This occurs when arc length and speed are correct, but instead of moving in a pattern like circles or a half moon shape, the operator just burns wherever he or she likes. This creates a non-uniform weld, which ends up leaving puddles that are not overlapped. At the start of your project, it's recommended to start with the butt weld first. Remember, before you weld any two pieces of metal together, make sure you tack them. Tacking is just making two smaller welds to make sure your metal doesn't move due to heat. Once the metal's been tacked, it'll look like this. Make sure if you're going to weld back over your tacks to remove the slag, as this slag could corrupt your weld. After you finish your weld, grab a pair of slip joint pliers and quench it before you knock your slag off. Next is the lap joint. As before, make sure you tack both sides before you weld. When welding the lap joint, keep the pattern movement to a minimum. Also, make sure the electrode is pointing directly into the crevice that the two pieces of lap metal make. Just like before, make sure you quench it before you chip the slag off of the weld. Before starting, remember to tack your piece of metal before you weld it. The T-joint is often considered by students to be the toughest joint to weld on the project. It is imperative that the rods stay directly in the joint and that the movement is again kept to a minimum. Like before, make sure you quench the weld before removing the slag. After cleaning, the project should resemble something like this. If you mess up on a weld, don't worry. Place a clear face shield over your head and use an angle grinder to grind the old weld off the joint. Make sure to flip the safety switch on the grinder paddle up or you won't be able to start the grinder. Apply gentle pressure to the weld and allow the grinder to do the work. Once the joint is clean, you can retry the weld.